Hello, welcome to my channel Devops with Prasanna. This is day 2 of Learn AWS in 30 Days series. So today we are going to talk about AWS networking. This is one of the hardest topics in AWS, but I'll make sure you will understand it properly. Yeah, we'll go into the session. That is one prerequisite before getting into the networking concepts like VPC, subnets, and things like that. That prerequisite is CIDR. Because we are going to use this notation. CIDR is a notation which will be used in all the places. It will be used in VPC, subnet, security group, NACL, in all the places of our networking side. So CIDR stands for classless interchange domain routing. There is a history to it. Like previously there were like a classful routing and then came the CIDR notation. But no one is using the classful routing now. So everyone started using CIDR only. So we'll focus on this one. What this means is it is a representation of a network, like how big the network is or how many IP addresses the network can have. It simply represents a network range, you can say. So this is an example of CIDR. So you can see like there are two parts to the CIDR. So this is the part number one, and this is the second part. Okay, the first part, this is called base IP, and this part is called subnet mask. So what is base, like for example, like okay, so this is like when you see a notation like this with IP address with slash and then some number, you'll know that is a CIDR notation. Okay, so to understand this range, network range, we have to understand this octets. So all the numbers here, or maybe like I'll use this one, all the numbers here are represented as octet, which means it one number is equivalent to 8 bits. So for example, 174 can be represented as 8 bits like this, and 0 can be represented like this. So this is the representation. But to make it simple, we are using the octet notation, which means we are using 0 and the numbers. But this number can go from 0 to 255 because that is the octet range. So if you, for example, if you start from here 00000, and then if you add 1 to it, this will be then if you add 1 to it, then it will be like 10. This is if you know the binary notation, this is represented as 2. This is represented as 1, and it will keep on going. And the last number in the series is everything is 1, which is 255. So which means there are totally 256 numbers which are represented. So this is a catch here. So what this means is each and every number here, it can have 256 values. Okay. So this can have 256 values, this can have 256 values, this can have 256, this can have 256 values. Okay. Now we'll come to the second part, which is the subnet mask. Let's say I have something like this, 174.16.0.0 slash 32. So what this means is, again, there are like two divisions to this. One is network address, the other one is host address. So this slash 32 represents the network address. So you can see like if it's 32 and if it's divided into octets, you can see there are 4 octets. What this means is all these 4 octets are used to represent a network address, which means the host address is just that only one address left over, which is 174.16.0.0. So that is the only address available in this network range. So what this slash 32 means is only one IP address is available. In our terms, like for example, if you want to create a virtual machine in this CADR, you can create only one virtual machine. So that's what it signifies. Let's say like instead of slash 32, we are having it as slash 16. So what this means is 174 and then 16. These two parts are used for network address, and the remaining these two numbers are used for host address. which means we can have these many IP addresses. So what this means, this number can have 256 IP addresses, and this number can have 256 IP addresses. Maybe I think like, yeah. So the combination is 256 into 256. So it can have that many number of IP addresses. I think if I give an example of /24, it will be like much more simpler. Mm, yeah, I'll say like /24, 32 and then /24. What 24 means is the first three numbers are used for network and last one number is used for host IP address. You know, like if the last one number, you can have 256 combination. So which means in this particular network range, you can create 256 VMs. That is the objective. Okay. Maybe like I should have, after 32, I should have gone to 24 because that is much more simpler to understand. And now if I say 16, it means like the two numbers, first two numbers are used for network, last two numbers are used for host, which means it's 256 into 256. You can create that many number of VMs. I think it's coming to 65536. You can create these many number of VMs with using this network range in the CIDR notation. Maybe like just to make it very clear, I'll go further. Like we'll take few examples and then we'll see how many number of machines can be created in this network range. So if for this combination, we know like there is only one VM can be created because it's /32. All the octets are used for network itself. If I say /24, the first three are used for network. Remaining one octet is available for us for the host, which means it will have 256 VMs. If I say 16, first two are 16 bits, which means 8 bits for this, 8 bits for the next number. 16 bits are used for network, and this is used for host, which means it's 256 into 256. It will give 65536 combination VMs. Okay. So this is how you can understand the CIDR notation. I know like it's a complex topic, but hopefully this should make it very simple to understand. If you have any questions, please let me know in the comments. I'll be happy to explain it further. I just want to talk about one more CIDR notation, which is 0.0.0.0/0. What this means is all IPs. So if I give a notation like this somewhere, it means whatever IP comes to this one, it will be falling in that range. So this is like we'll use a wildcard star, right? So it's similar to that wildcard star. Now comes a challenging part. So I took a very simple examples, so it was very easy to do the calculation. And now I'll say a complex scenario. For example, I'm giving a scenario something like /20. So what this 20 means is 20 bits are used for network address, which means if I go here, if I take this one, this here it is 8, and then 8, 16, and then out of this only 4 is being used. So till this part, it is network IP, network address, and all the remaining these things are host address, which is not a straightforward thing to calculate, right? So what I did is there is a link which we can go and see. So IP address guide/CIDR. So if we go here, IP address CIDR, we can give our range 172.8.10.12. So 172.8.10.12/20. And if we ask this to calculate the range, you can see the first IP address is 172.8.0.0 and the last IP is 172.15.255. Totally 4096 hosts can be created. So if you see something like /20, this is what it represents. Like the first 20 bits represent the network, The remaining bits, which is like 12 bits, it represents the host address. So there are like 4096 combination. That's what you can get. Okay, so this is like a complicated topic, but I think we explained that in 10 minutes. Hopefully, like you should understand this also. If you have any doubts, please watch the video again because this is an important concept which you need to grasp. Now we'll go into the VPC networking, actual AWS networking. So there are few concepts which you need to understand before getting going further into the demo and things like that, which is VPC, subnets, route tables. VPC. So till now we discussed AWS. AWS is a cloud provider, so that itself is a cloud computing system, and AWS is a cloud. Within that, we are going to have one more cloud. That's what called as VPC. It is virtual private cloud. So how we have VMs, virtual machine, not the actual machine, but the virtual machine created using hypervisor. This is a virtual private cloud which is created for each and every client. So we created a new EC2 instance and we created an AWS account. So by default, VPC is created for us, and by default, a subnet is created for us. Just that we didn't go and check that one, but we are going to do that in today's session. So that is the concept of a virtual private cloud. And why we are following this approach is it gives a security aspect. It's for the security aspect. So for example, if you create a virtual private cloud, that cloud, all the machines within that cloud will be accessible only by your company. And if another AWS account got created, that will have its own virtual private cloud. So this gives a isolation. Yeah. So I'll try to explain the subnets and route tables using this simple diagram. So this is a very simple representation of VPC and subnets. In this, this is a AWS cloud, and within that we have one VPC. Within this VPC, we have two subnets. Subnets, it's nothing but compartments within the VPC. So you are given a cloud. Now you have to create compartments within the cloud so you can assign a type to that cloud. So type to that subnet. So the type in the sense it can be either public subnet or private subnet. So public subnet is something which can be accessed from the outside world. We created a EC2 instance in the previous session. So if you didn't watch the previous session, I'll link it here so you can go and check it out. That instance got created in the public subnet, so that's why like we could able to create a Apache server and then access it from the browser. And the opposite of this is the private subnet, which means it is not accessible from the outside world. So it might ask like why we want to have something like private subnet, which no one can access. And this is the most important aspect in the best practices to be followed. For example, if you have a database in your a part of your application, all the database servers or Elastic Cache or your Elasticsearch or Redis, everything, all the data storage should be part of private subnet. The reason for that is all this data storage are going to be accessed by your web server only, not directly by the end user or the outside people. So it is for the security purpose, you should always create the database server within private subnet, and you should give access to the only to this web server to access the database. So this is a minimal access policy. So only your web server should access the database. That is the catch. Okay, so this is clear. So there are two subnets, public and private subnet. And how to distinguish between public subnet and private subnet? It is very straightforward. So all the public subnets will have internet gateway attached to it, and all the private subnet. I mean all because if you don't have a like all the private subnet will have NAT gateway attached to it. If you don't have the NAT gateway attached, which means there is no traffic which can be sent from this private subnet to the outside world. Like there are two kind of traffic which we want to understand. For example, the traffic which is coming inside, it is called as ingress traffic. It is called ingress or it called as inbound traffic. Okay, and all the traffic which goes from the subnet to the outside world, it is called as egress traffic or outbound traffic. Okay, so if you don't attach a NAT gateway to a subnet, what will happen is no egress traffic will be sent. So what is the problem with this? Let's say like you have a EC2 instance, database server EC2 instance, and you want to do yum update, like what we did before, or you want to install a Postgres database. You can't do that because this server can't access Google or like whatever site it is because there is no NAT gateway attached to it. So this might be like an interview question, or it could be a scenario which you are facing in the day-to-day job. For example, you have a private subnet, but you couldn't reach to the internet, which means that is the NAT gateway is not properly configured. So that is the case. So how does NAT gateway works, or like what is mean by NAT? So NAT stands for Network Address Translation. Um, and yeah, maybe like yeah. So NAT stands for Network Address Translation. Let's say like you have a database server, it will be having a private IP address. Let's say 16.1.1. Let's say this is a private IP address of this machine, and you want to talk to let's say like a yum package manager or somewhere. So this will route the traffic to NAT gateway. NAT gateway will have the address stored in the translation table, and then it will contact internet gateway, and internet gateway will route the traffic to outside world. And from outside world, the response will come back inside, and it will go to the NAT gateway. NAT gateway will look up the corresponding IP address, private IP address of the server, and then it will route the traffic to the proper EC2 instance. So this translation is happening in the NAT gateway. So that is the sole purpose of NAT gateway. And this NAT gateway will always be available in public subnet. So you should create the NAT gateway in public subnet, but you will attach this NAT gateway to the private subnet. That is a catch here. So like I'm saying about like attaching internet gateway to public subnet, attaching NAT gateway to private subnet. What is meant by attaching? Attaching means adding an entry in the route table. So all this is happening via something called as router, and it will have its own route table. So for example, it will have something the entry like this. So the entry will be something like this. Let's say for 0.0.0.0/0, you know like what the CIDR means now, right? So this is wildcard CIDR notation. Like all the traffic, send it to NAT gateway. This there will be entry like this in the route table, and because of this entry, this whole egress traffic and then the response will be coming properly to the corresponding machine. And we are going to see everything in the AWS console now in the demo part. But I just want to make sure like you understand this concepts properly. And similarly, in the route table of this subnet, public subnet, you will have an entry like this 0.0.0.0/0. It will use internet gateway and route all the traffic. So this is what the attaching means. So we are attaching internet gateway to the public subnet. We are attaching NAT gateway to the private subnet and setting up the whole system. And you know what? Like we just created the AWS account. We didn't do any of this setup, but still it was working fine. The reason for that is all the setup are by default done by AWS for us. So the default VPC, the default subnets are created, and the default route table entries are also created. Else it will be like very difficult to create even one machine because we have to understand this whole concept. You have to do the like the notations properly, and then only you should be able to create a machine, which is like very tedious. So AWS made it very simple by giving all the default default VPC subnets for us. Yeah, before going into the hands-on demo, I just want to explain one more concept, which is NACL and security group. So we slightly touched upon the security group in the previous session, but we'll see it again here. So I made a very simple diagram so that like you'll focus only on NACL and ST, not other aspects of private subnet, public subnet, things like that. Okay, so NACL stands for Network Access Control List, which means this is again a set of rules. Yeah. So this is again a set of rules which will define like what is the incoming traffic allowed, what is the outgoing traffic allowed. So that will be like rules which will be applicable for the subnet. So NACL will always applies to the subnet level at the subnet level, which means if we say don't allow this CIDR notation at the NACL level, then whatever we have in the ST security group level doesn't make any sense because all the traffic will be stopped at this level itself, and no traffic will be routed inside the subnet. Okay, and let's take an example where we are allowing the traffic. So the traffic is going to the EC2 instance, but there is a component called security group before every EC2 instance. This will make sure like this is again a set of rules. So this is again rules which will say like whether this CIDR notation is allowed to access this instance or not. Along with that CIDR notation, there is one more concept called port. So in the previous example, the port for us is 80, which is the port for Apache. So we have to give this combination of the CIDR plus port to allow or not. So that is a list set of rules which we are going to have at the security group level. And there is a slight difference between the NACL rules and the security group rules. NACL rules is stateless routing. Stateless in the sense you have to define rules for both inbound and outbound. So we discussed about inbound, right? Like incoming traffic and outgoing traffic. So we have to define the rules separately. So for example, in some cases you can have only the inbound rules, but the outbound rules can be like blocked. But the security groups are always stateful, which means if you allow a incoming traffic, outgoing traffic is allowed by default. So this is a difference between NACL and security group. NACL applies at the subnet level, security group applies at the EC2 instance level, and NACL is stateless routing, security group is stateful routing. So in the demo, we are going to see about this NACL and security group also. And to make things simple, I'm not going to create a new VPC, new subnet and things like that. I'm going to show you the default VPC and subnets and the route tables which is coming with AWS. And we'll see how this maps with the understanding which we have. Okay, we'll go into the hands-on. Okay, so this is our AWS console. And here, now we are going to go into VPC. So if you check VPC here, there is one VPC which got created by default. There is no name to it. And all the VPCs will have a CIDR notation. So now hopefully you should understand what this means. Like 172.31.0.0, out of which 16 bits, which is the first two things, are allocated for the network address. And the next two octets are allocated for the host address, which means all the EC2 instance within this VPC will have the prefix of 172.31. Then you can have something like that. So that will be the private IP of all the EC2 instance which is created within this VPC. And so like if we go into the subnets, just a moment. Yeah, if we go into the subnet, we have three subnets here. And subnet is a compartment within the VPC. So the subnet should also have the same like subnet should belong to that VPC CIDR notation. So for example, you can see things like 172.31, which is a network address, and 16.0. And here you can see like 20 bits, which is a complicated scenario which we discussed. Which means in this 16, the number 16, first 4 bits are allocated to network, and the remaining 4 bits and the last octet is allocated to the host IP address range. So which means there are like 4091 IP address available. I think we saw around like 4096, but 5 IP address will be used by AWS for the router and to configure things like that. So effectively like 4091 IP address are available for us because of this /20 subnet mask. And similarly, there is one more subnet. There are actually like 3 subnets, which is coming by default when we create a AWS account. And I forgot to mention one thing here. Each and every subnet will be associated to a availability zone. So we talked about availability zone and region before, right? So in the first session. So this AZ is the actual data center. So all the machines which we create within this subnet will belong to this availability zone only, which means a particular data center. Okay. Yeah. So this is the subnets which we have. And the next concept which we talked about is to understand. So like we have 3 subnets. We want to know like which subnet is private subnet and which subnet is a public subnet. If you remember from the session, we know like if you see the route table, if a subnet is attached to an internet gateway, then that subnet is a public subnet. If a subnet is attached to a NAT gateway, then that is a private subnet. So we'll see the route table. So there are 2 entries in this route table. This is an interesting one for us. We'll see about this later. This 0.0.0.0, which is a wildcard CIDR. So all the IP address, if it belongs to this range, it will be using IGW, short form for Internet Gateway. So it will, which means this subnet is attached to this Internet Gateway, and that means it's a public subnet. Okay, and we'll go into the second one. Here also, this CIDR notation attached to Internet Gateway, which means this is also a public subnet. And the last one, this is attached to Internet Gateway, and this is also a public subnet. So by default, AWS creates 3 subnets for us, and all the 3 subnets are public subnet, which means if you create a mission within this any of the subnets, and if you enable the public IP address, then it means like the traffic can be routed to that mission, and we can get the response back. That is the objective. And the reason for not having a private subnet by default is private subnet, the NAT gateway will incur charges. So if I create a NAT gateway, it'll be charged per hour basis. So that is also one more reason why I don't want to create the NAT gateway now. Yeah, so we saw the subnets, we saw the route tables, and we want to see the NACL rules, the network access control list. Yeah, before that, I just want to talk about these 2 destinations. The first destination is just 172.31.0.0/16. For example, you are trying to talk to one more mission within the same VPC. Okay. So in this case, let's say like there is one more VPC sitting here. Sorry, one more VM sitting here, VM2. If these 2 missions want to communicate, that should be like no internet gateway needed for it. Like this communication should be like a private network level communication. So which means if address starts with this range 172.31, and I don't worry about last 2 octets, it can be any octet. Which means if I'm trying to talk to some mission within the VPC, then I should be able to use the target as local. This by default will say this mission is available within the VPC. So talk to the mission directly via VPC. Don't go via the internet to talk to that mission. So that is the idea. So all the missions within that VPC can talk to each other. but no other person from the outside world can talk to that machine. So yeah, so this is clear. We talked about routines. Now we want to talk about NACL and security group. Network ACL. As we saw earlier, this is nothing but set of rules. So the rule number 100 means it will take the highest precedence. If I say, if I create a rule with the number 1, then that will be the highest precedence rule. And if I say rule with 1000, then it means like it will be the lowest precedence. I think it can have up to 65536 or some big number like that. So in this case, what's happening is rule number 100, which is a high priority rule, it's saying like all traffic, all protocol, all port range from all the destination are allowed by default. So this is what it's saying. So there is no restriction at the NACL level. So if, for example, to come back to this diagram, we are saying like whatever traffic comes to this subnet, please allow that traffic. Let's say like if you miss something here, if you uh, if you give a CIDR notation and if you don't allow a traffic, it will be like very difficult to debug the things because you'll go and see the security group. Security group will be proper, but at NACL level, it might be blocked. So be very conscious in blocking the traffic, in denying the traffic. Usually, like unless in service it is actually needed, don't touch the NACL rule. Like operate at the security group level, which is much more simpler. And we'll see about the security group now. Yeah. So what I'll do is I'll go to EC2 instance, which we created in the previous section. And we'll see the security group for this. So like in the last session, we gave the security group as allow HTTP traffic. So there is a security tab here. And there is one security group which got created by default. And you can see there are two rules in the security group. One rule is port 80 from 0000, which means from all the IP address. That is allowed. And port 22, which is used for SSH. That is also allowed. And outbound rules is also like allowed for everything. These are the two things which is allowed to this machine. Now what I'll do is, let's say like I'll try to do a ping. So I'll copy this public IP address and I'll go to my command line. I'll say ping and then I'll give this IP address. So ping uses ICMP protocol and you can see all the requests are timing out. Even though this machine belongs to public subnet and there is a NACL rule which is allowing the traffic to that machine, still I couldn't do the ping to this IP address. The reason for that is ping is not allowed at the security group level. Now what I'll do is I'll go to this security group. These are the list of rules available. I'll edit the inbound rules. I'll add one more rule which will say all ICMP traffic and from anywhere IPv4, which means 0.0.0.0 again, wildcard notation. Save the rules. And if I go here, if I do the same ping again, you can see all the ping are successful. So it's saying like it transmitted 5 package and it received the 5 package. Yeah. So 5 packet transmitted, 5 packet received. So 100 like 0% packet loss, which means ping is successful. That is because we allowed the traffic ICMP from all the places. Yeah, so hopefully this should cover the details of networking at the VPC level and networking at the instance group level. So if you have any questions or if you need any clarifications about any of this topic, please let me know in comments. Happy to help you. Yeah, happy learning. Bye bye.